Hello students, this is topic 6, rules for drawing ray diagrams. These rules are very important. Unless and until you know these rules, you will not be able to draw the ray diagram. It's because the rays, when they come from any source, then they diverge at every point, right? So in which particular point they will cross, that we don't know, and how they will behave after reflection, that is also been told in the rule. So you have to by heart all these rules. These does not come in the examination. It has never came in the examination till now, but this is important for you to remember this and then to apply it while drawing the ray diagram. Okay, so we'll start with the rules for drawing the ray diagram, and this is rule number 1. We are going to write here. I am going to draw here. What the rule number 1 says is that when the ray is parallel to the principal axis. Now, before knowing what the rule says, let me draw here the concave mirror. We will be drawing the rules equally for concave mirror as well as for convex mirror. So, this is concave mirror and this is convex mirror, right. So, if this is the principal axis, this is focus, this is center of curvature. So, let us say if the ray is coming parallel to the principal axis, this is a ray which is coming parallel to the principal axis. Then after reflection from this particular surface, it is going to bend. And how it is going to bend? In concave mirror, it is going to bend which side, inward or outward? It is going to bend inward, right. So, after reflection from this mirror, it is going to pass from focus. That means, of course, they are going to bend inward, but then it has 3 points here, P, F and C. From where it is going to pass? It has to pass from the focus. That's rule number 1. Okay. For convex mirror, if this is the principal axis, this is point P, this is F and this is point C. So, the ray is going to come. See, you have to consider this particular thing. If I finish this circle over here, this is going to complete on this particular side, right. So, where will be the center of curvature? On my right hand side for a convex mirror. This is the back side of the convex mirror. It is not always necessary that wherever the reflecting surface is, you have to make the center of curvature and focal point in front of it. It's not so necessary. The point is that wherever the curvature finishes, that particular side will be the center of curvature and the focus, principal focus, right. So, now if a ray is coming parallel to the principal axis, this is a ray considering parallel to the principal axis, and after reflection, it is not going to bend inward, rather it is going to bend outward. Now, if you proceed this one, this is surely going to meet where? At F. So, that is rule number 1, that if the incident ray is parallel to the principal axis, this is the principal axis, then after reflection from the mirror, concave mirror and convex mirror, it passes from focus in case of concave mirror and it diverges from here in case of convex mirror. Okay, that is the rule number 1. The next rule is rule number 2, says just the reverse of it. Rule 2. Rule 2, according to it, if a ray is passing from focus, now this is the ray, okay, this is an incident ray, it is passing from focus, then after reflection from this particular point, it becomes parallel to the principal axis. You might ask that, the question can come to you in your mind that what if the ray is passed like this from downward, this can also happen, then the ray is going to be parallel like this. Okay, so it does not matter from where the ray is coming, from top to bottom or from bottom to top, it will become parallel if it is passing from the focus. That is the point you have to remember. Fine. So, this is done. The next one is just reverse of it, that is convex mirror. Convex mirror is a pole here, this is the focus, this is the center of curvature, and if the ray is coming toward the focus, now see, it cannot directly hit here. Why? Because this is the back side, right? So just as I show you this mirror, if a ray comes from here, this is an opaque surface. The ray cannot penetrate through this opaque surface, so it cannot penetrate through here. But we assume that if it is going to the focus, then in this condition, after the reflection, it becomes parallel to the principal axis. This is how it is going to behave. Or if it is coming like this from bottom, that means if you proceed, it should meet at focus. In that condition, it will become parallel to the principal axis, right? So this is the second rule, rule number 2. So this is rule 3 for a concave mirror. This is pole, focus, center of curvature. Now if a ray is such that it is incident ray is coming and it is passing from the center of curvature like this. This is the incident ray, right? So after reflection from here, it is not going to go anywhere. It is going to retrace its path. You can see the arrows are made on the opposite direction. That means this ray is not going to go anywhere. So same for the convex mirror also. This is the convex mirror. This is point P, F and C. This ray is coming toward center of curvature. If we proceed this will meet at center of curvature. This one is not meeting at focus. You have to understand this particular part. Then it is again going to retrace its path backward. This happens only with center of curvature. Okay. And why it happens? Now that's a big question. Why? Why does it happen with center of curvature only? Now I will leave it up to you to think, and after telling rule number 4, I'll tell you the reason. Okay. Till that time you can give a thought about it, why it will retrace its path backward. Coming to rule number 4, this is the last rule. This is concave mirror and principal axis. This is focus, center of curvature. We have made the ray pass through focus, center of curvature, parallel also. The only one point which is left is pole. Now if the ray comes obliquely like this, of course coming toward pole, it has to oblique. Then after reflection from here, it will pass obliquely like this, making angle I and angle R equal. That's the first law of reflection also. That means principal axis will be playing the role of normal here, and the same diagram will be for convex mirror. That means here for this particular diagram there will be no change. See, the diagram remains same for concave as well as for convex. For the other rule there was a change in the diagram, but for this case it will be the same, making angle I and R same, right? So this is done. Now we are coming back to the particular part. Before that, a very important point, this thing you need to remember, very important thing to note is that do not forget to mark arrows. Whenever we mark any particular line, it should has arrow. Incident ray, reflected ray. See, everywhere I have drawn this arrow, right? This one, everywhere you can see this one. Everywhere we have drawn the arrow. That means this is a very important point, because if you do not write this particular part, mark this particular part, then you can see minus half. That is, half mark will be deducted. Okay, this is the rule for every type of board, whichever board you appear. This thing you have to remember. Okay, so in rule 3, I told you that if a ray comes towards center of curvature, drawing it here for concave mirror, if a rule 3 says that if a ray, incident ray, comes toward the center of curvature, then after reflection it retraces its path backward. My question was why why this happens, why it will retrace its path backward. So if you have guessed it, it's very good. If not, I'm telling you the answer here. See, this has formed from a spherical mirror. This spherical mirrors are formed from a sphere, right, which has a particular center. That center is known as what? Center of curvature. If any line is passed from center of curvature, which is reaching to the other end also, where is the other end? That is the pole. In this particular point, pole is where? Pole is at the rim of this spherical surface, that is at the circumference. So if you join any point from the circumference to till the center point of the circle, what does it form? It forms a radius, and if you elongate this line, then it becomes what? A diameter. Similarly, if you pass any ray like this becomes a principal axis. I am just relating these two figures. You have to consider this as a concave mirror, just like here. This is a pole, this is the focal point, principal focus, which is not required in this diagram right now. This is the principal axis. The ray came from here, like this. See? Now this ray is also one of the diameter. Why? Because it is passing from the center, and it is also touching the two extreme points of the circle, so of the sphere in this particular case. So that's why whenever it passes from the center of curvature and when it hits at this particular end, so according to the theorem in the mathematics, that when the radius touch the part of the circumference, then what happens to it? What angles does it makes? It makes 90 degree. Right? So that means this line which is hitting here at this particular end, how much angle it is going to make? It is going to make 90 degree angle. So what happens when a ray enters with a 90 degree angle? If this is a normal, this is making 90 degree angle, right? So if a ray enters from a normal, what happens to it? It reflects back into that same line. The same thing happens here also. The only difference is that here the surface was horizontal, here the surface was curved, and that same thing we are relating here also. So that's the point, that whenever the ray passes from center of curvature, then the point wherever it hits the mirror, the angle that it makes with the mirror is 90 degree, and therefore it does not deviate anywhere and it retraces its path backward. So I hope you have understood all the rules. Go through the rules, by heart them, and after you know all the rules, we will be dealing with the next lecture, in which we will be drawing the ray diagrams, okay, for the spherical mirrors. Till then, if there is any doubt, please write in the comment section, and all the notes are provided in the description box and in the ERP. Thank you.